Welcome. In this session, we'll summarize the important observation about the behavior of the capacitor voltage if we connect our disconnect our source to this capacitor. Let's start. Now, in the previous session, we learned if we connect our source or disconnect our source to an RC circuit, what happens to the capacitor voltage. So, in the previous session, we learned if we connect our source to an RC circuit, what is the behavior of this capacitor voltage? Now, if the capacitor is, in the first observation that we have, if the capacitor is initially uncharged, means if it has no energy stored. So if capacitor has no energy stored, then when we connect this switch to position 1, then if we connect the switch at position 1, then that means, in other words, we are connecting the source Vs to this RC circuit, then the capacitor voltage rises exponentially. And the equation is given by this. Then the Vc of t is equal to Vs 1 minus e to the power of t by tau, where tau is the time constant of this capacitor and it's given by RC. All right. And in steady state, and the value of the capacitor approaches to the steady state value, and the steady state value are the final value of the capacitor voltage that you can see from this. If when t is equal to infinity, this term will be 0 is Vs. So, but we have assumed the steady state value or the steady state condition of the network arises when time is 5 tau. Then the steady state value of the capacitor voltage is equal to Vs, means it finally charges to this supply voltage. And in this steady state, the energy stored in the capacitor is maximum. So it stores maximum energy, and the value of that energy is 1/2 of CV S square, where Vs is the voltage stored in this capacitor. So this is the first observation. If we connect a source to an RC network which has no initial energy stored, then the capacitor voltage rises exponentially, and having the behavior that is governed by this expression. Then in steady state, which arrives after 5 time constants, the capacitor finally fully charges to the battery voltage and stores the maximum energy of 1/2 of CV square, where V is the voltage of the capacitor. Now, the second observation that we have about this capacitor is if it is initially relaxed, it means if it stores no energy. If the capacitor stores no energy, so if capacitor stores no energy initially, then if we close the switch at t equal to 0, means if we connect to the source at t equal to 0, if we connect to the at t equal to 0, then what is the value of the voltage stored in this capacitor at t equal to 0? This term is 1, so it is 1 minus 1, so 0. So the voltage stored in the capacitor is from this expression at t equal to 0 is equal to 0. Similarly, the current flowing in the capacitor at t equal to 0 will be simply Vs divided by R e to the power of minus t by tau. And from this, you can say at t equal to 0, the value of this current is simply Vs by R. So what is this saying? So when we connect to this source, this RC circuit to the source, the capacitor behaves like a short circuit. So initially at t equal to 0, capacitor behaves like a short circuit. This is very, very important observation. Capacitor behaves like a short circuit initially. Okay, if we connected this to a source. Why? Because the voltage is 0, but the current is flowing, and the current that's flowing is like this. Now, at t equal to 5 time constant or in steady state. In steady state, what is the second observation from this? In steady state, and actual steady state arrives at t equal to infinity, but we have assumed for all practical purpose the steady state arrives after 5 time is equal to 5 time constants. So in steady state, the voltage stored in the capacitor Vc of t from this expression is equal to Vs, and current from this in steady state will be equal to simply 0 from this, because this term is equal to 0. So what is this capacitor behaving as? This is behaving like a voltage source, open circuit voltage source. In other words, it is behaving like a capacitor behaves like an open circuit element. How? Because there is voltage, but there is no current. So we say this element is open circuit. Now again, please remember this. Capacitor does not open like this, means the elements do not separate, the two plates do not separate, means they separate far enough. No, it doesn't happen like this. In other words, it happens in terms of V and I. What do I mean by that? Means when the capacitor acquires a full voltage, when it's connected to this position, when the capacitor is connected to this position 1, and when it charges fully. So what is the voltage drop across the capacitor? Resistor 0, because the voltage on this side is Vs, voltage on this side is Vs, means the voltage difference across this resistor is 0, so there will be no current flow. In other words, it charges fully and behaves like, acts like an open circuit. Means now the current cannot flow. That's the meaning of open circuit here. Please remember this point. Third important observation is very, very important observation that will be very useful for the examples that will follow after this. Capacitor voltage cannot change instantaneously. What do I mean by that? Means Vc of 0 minus what is the value of the capacitor voltage prior to switching will be same as just after this switching time instant. Means what is the value of the capacitor voltage just before the switching? The capacitor voltage will be same just after this switching time instant. Now the fourth important observation is when we remove the source from this RC circuit. What I am saying, when we move the position of this switch from 1 to 2, means initially it was connected to 1, and it is the capacitor is supposed to fully charge to Vs. Then when we remove this supply, then when we remove the supply, then the capacitor behaves like an active source. Active source and loses its energy. Now the voltage decay. Now the voltage decay in the capacitor is given by the voltage decay after you disconnect it from the source is given by V of t, means Vc of t will be equal to Vs e to the power of t by tau, means it decays by following this expression. And at steady state, this is very, very important. At steady state, when will the steady state condition arrive? After you disconnect, after 5 time constants. In steady state, there is no energy present. No energy is present in capacitor. In other words, what do I mean by that? Vc of t at t equal to 5 time constant is equal to 0. Means now that and the capacitor is fully discharged. So when you remove this source, or in other words, when you change the position of the switch from 1 to 2, then the capacitor behaves like an active source for some time and loses its energy. And the decay in the voltage follows this expression. And after 5 time constants, the total voltage stored in the capacitor will be 0. All right. So these are some important observations about this capacitor. Let me end this session here.